our last video, we were introduced to the concept of a surd. So in other words, an irrational number that is better off left under the root sign because it's going to be a more accurate answer. Otherwise, we end up with a non-recurring, non-terminating decimal. Okay, but another thing you might notice is that if you were to pick up your calculator and type this in, it would actually equate to something different. And that is because we generally want our fractions to have rational denominators. So a surd represents an irrational number. We would need to then rationalize it so that we end up with a rational fraction. Okay, or a rational denominator. And the way you do this is quite straightforward. We simply want to multiply by 1. Okay, because if I times anything by 1, I just end up with the thing that I started with. So 5 over root 5 times by 1 will be equal to exactly the same thing. But what we need to do is we need to be crafty about how we multiply by 1. And so what we want to do essentially is get rid of that root sign in the denominator. So what I know is that root of 5 times root of 5 is just equal to 5. And so what I multiply by in the denom, I need to multiply by in the numerator. Okay, and so this is going to rationalize the fraction perfectly. I'm going to end up with 5 multiplied by root of 5 over 5. And that can actually simplify again. 5 goes into 5 once, and so this simplifies perfectly to the root of 5. Now you can check that out on your calculator. Type in 5 over root of 5 and have a look at how it rationalizes it for you automatically. Now that's great, and the calculator is so helpful to have, but we will often be asked to show all of our calculations or to rationalize without using a calculator, and that's where you need to understand we multiply by 1, but we do it craftily. Okay, if we have a look at this next example here, number 2, x plus 2 in our numerator over 2 root 3 in the denominator, and we need to rationalize this. So what I need to do is I need to get rid of that root 3 in the denominator, and I can do that by multiplying it by root 3, and what I do to the denominator, I do to the numerator. So let's have a look at what's going to happen now as I bring these two fractions together. We're going to end up with root of 3 multiplied by the numerator there, over 2 times root of 3 times root of 3 is just 3. So that's going to then be, let's multiply this in, so it's going to be x root 3 plus 2 root 3 over 6 as our rationalized answer. Okay, one thing to note is that if you are ever asked to rationalize something that's a little bit more complicated, this one has 2 terms in the denominator. And what you'd see is if I multiplied by root 2 over root 2, I would then end up with a root 2 again. It's like it wouldn't go away because I'd have to multiply that in. So what we then need to do is you multiply by what is called the conjugate. So we want to take this 1 and root 2, and we want to use difference of squares to help us get rid of that root sign in the denominator. So since this one here was a negative, we're going to make this denominator here a positive. And then I want this fraction to equal 1, so I'm going to need to do the positive in the top 2. Okay, this might be looking stressful to you, but have a look at how it's going to pan out. So we're going to have 3 times 1 plus the conjugate there, root 2, over, in the bottom here, we're going to have 1 minus root 2, 1 plus root 2. Okay, and then if we FOIL that out, well, let's first of all distribute there in the numerator. So 3 times 1, 3 times root of 2. So 3 plus 3 root 2. And then in our denominator, let's quickly FOIL this, and then you'll see what's going to happen. Our middle terms will cancel. So first, outer, inner, last. First, 1 times 1, then inner, or outer, 1 times root of 2, so plus 1 root 2, then inner, minus root 2 times 1, and then finally last, minus times a plus, and root 2 times root 2. So what's happening now is that those middle terms are going away, and so we are ending up with something that looks like this. 3 plus 3 root 2 over 1 minus 2. And 1 minus 2 is minus 1. So it's going to be this numerator divided by minus 1, which means I can simply change the signs. Minus 3 minus 3 root 2 there would be my final answer. Sometimes rationalizing fractions comes in a bit of a sneaky question. Okay, so if you look at this, what they've given us is 6 over root of 2, and they've said it equals to n root t, and now they say determine the values of n and t. Okay, so whenever you're not sure what to do, this here in the denominator needs to send off a warning sign. Okay, this gives us an opportunity to rationalize. Okay, and it's a nice easy rationalized question. So we can take what they've given us, 6 over the root of 2, and we can multiply it by, what do we want to get rid of? Root of 2. And what I do in the denominator, I do in the numerator. Okay, so what does that end up being? It ends up being 6 root 2 over root 2 times root 2 is just 2. And then we can simplify. 2 goes into 2 once and into 6 3 times. So have a look what's happened now. We have rationalized this, and in many ways it's so much simpler. It's now 3 root 2. Okay, now we can link it to what they told us up there in the question, n root t. Have a look at that. N is written in the same place as the 3, and t is written in the same place as the 2. So we can now say, well, n is equal to 3, and t is equal to 2. Right, we had a look at all of these laws of exponents in our last video. We saw that we can multiply the bases and add the exponents, divide the bases, subtract the exponents. When you raise a power to a power, you multiply that power into all of the exponents. Anything to the power of 0 is equal to 1. Negative exponents can be written as fractions, and then we have positive exponents. And finally, when dealing with a root, you take the inside power over the outside root, and that gives you a simplified exponent. Okay, all of these laws of exponents are so helpful, especially when we multiply and divide bases. But what we're going to look at now is a couple of examples where we first need to factorize before we can tackle that. So let's do that, and then we'll bring everything together in some helpful examples. Factorize the following. We've got 3 to the x plus 2 minus 3 to the x plus 4. Okay, so if you think about those laws of exponents that we raced through just now, you'll see that there wasn't one for subtracting the bases. So whenever you subtract the bases or add the bases, you need to factorize. That's something that would be a very good habit to get into. Okay, what I like to do is I like to break it up. It just helps me to visualize. So this can be written as 3 to the x times 3 to the 2 minus 3 to the x times 3 to the 4. Okay, why do I like this? Because it helps me to see that there's a common denominator here, a common factor. 3 to the x is part of both of those terms. So I can factor that out, and I can say, well, that's 3 to the x, and then what's left? 3 squared minus 3 to the 4. Okay, and that is easy enough to simplify. 3 to the x, 9 minus 3 to the power of 4. And so we can just write that down as 3 to the x times by minus 72. And in general, although I don't think you'd lose any marks if you didn't do it, but it's nice to put that constant term without the exponent in front. So minus 72 times 3 to the x once we've factorized it. Now to tackle this next example, we're dealing with 2 to the 2x, 2 to the x plus 1 minus 8. What we need to try to identify is that this looks like a trinomial, except now I'm used to x squared, not the 2x there, and I'm used to x, just a normal x here, and then a constant term there at the end. So what I advise is that you get ready to substitute out. Let's try and make it familiar. So if we say let k equal 2 to the power of x, I believe this is going to be a lot easier for us to tackle. Okay, so the first thing I'm going to do is I'm just going to get it ready. So I'm going to change this to 2 to the x squared, because the rule says if I raise a power to a power, I multiply them. So I'm allowed to do that. Then I'm going to break that second term up, and I'm going to make it 2 to the x times by 2 to the 1. So just times by 2. Minus 8. Okay, and that helps me because now I can see everywhere that I've got a 2 to the x, I can substitute it with k. That was the plan. So I'm trying to just make this an ordinary factorizing trinomial. So plus k times 2 minus 8. And so actually what this is, k squared plus 2k minus 8. And I know how to factorize this. Factors of 8, 1 times 8, 2 times 4. Which of those pairs will give me the positive 2 I'm looking for? It'll be this pair here. So I can then factor that out, and I can say k plus 4, k minus 2. And now I can substitute back in, and I can say this is 2 to the x plus 4 in one bracket, and 2 to the x minus 2 in the other bracket. Okay, so now I've factorized with exponents, which is a very helpful skill for grade 11 exponential expressions. And because I've done that, I've ended up with my 2 brackets here. Okay, you can, if you want to, pause this video, multiply these out, and have a look. You will end up back at this trinomial here. Now, questions like this are the reason why we need to know how to factorize trinomials. Okay, so here, straight away I identify a negative, which means I need to factorize this before I can cancel anything. If I was multiplying or dividing, I could straight away apply the laws of exponents, but this is not the case. Okay, so I'm going to start, and I'm just going to break it up. 2 to the x, 2 to the minus 3, minus 3 times 2 to the x, 2 to the minus 1, over 2 to the x, 2 to the minus 2. Okay, that helps me to identify that in my numerator, I do have a common 2 to the x that I can factor out. So let's do that. We'll have 2 to the x. Inside our bracket will be 2 to the minus 3 minus 3 times 2 to the minus 1 over 2 to the x times 2 to the minus 2. Now that it is factorized, we are allowed to cancel. So that makes our life a little bit better. And now we just have to sit here without the use of a calculator. So be careful there. We have to now solve this step by step. Okay, 2 to the power of minus 3, that's the same as 1 over 8, because 2 times 2 times 2, and it's a negative, so we're going to take it to the bottom, multiplied by 3 times 2 to the power of minus 1, so we can write it like that. And then that is all going to be divided by 1 over 2 squared, which is 4. Okay, so what I've done is I have now taken this fraction line, and I've rather written it as a division sign there. It just helps me to solve. Okay, so let's get a common denominator here. 1 over 8 minus, let's put this also over 8. So that means times 4 times 4. 3 times 4 is 12. Divided by, in fact, we can even change that already. We know just now we're going to multiply. So we can tip and times. Multiply by 4 over 1. Okay. So we end up with 1 minus 12, so minus 11 over 8 times 4 over 1. And then let's just cancel what we can. 4 goes into 4 once and into 8 twice. And so this we can then leave as minus 11 over 2 as our final answer. Let's tackle one more example. Okay, so we've got 5 to the 1 minus 2x plus 25 to the minus x over 5 to the x plus 1 to the minus 2. Okay, we've got a couple things here. 5, 5, 25. Let's get that in prime bases. And then also let's raise a power to a power here, just so that things start to be in the form that we need in order for us to actually simplify this fraction. Okay, so 5 to the 1 minus 2x. I'm going to leave it just like that for now. And I'm going to rewrite this as 5 squared. Okay, so it's going to end up being, let's do that calculation up here, 5 squared to the minus x. So we're going to multiply that. So it ends up being 5 to the minus 2x once we simplify that over 5 to the minus 2x minus 2. Okay, so all I did there was multiply that in each time. Okay, now I'm going to break it up because that's always easier for me to factorize. So we've got 5 to the 1 times 5 to the minus 2x plus 5 to the minus 2x over 5 to the minus 2x times 5 to the minus 2. Okay, let's see what's common here that I can factorize out. This is a common term. Okay, be very careful here. If you were to take this whole term out, this 5 to the minus 2x, it is still technically multiplying by 1. So don't just leave an empty space in your bracket. We're going to take out a 5 to the minus 2x. In the first term, we're going to be left with 5 to the 1, so just 5, plus in the second term, because we've taken everything, we'll just be left with that 1 that we need to multiply it by. Okay, and then this is 5 to the minus 2x times 5 to the minus 2. So this is very good news because a lot of my negative exponents are actually dealing with themselves. They've gone away. They cancel. Okay, so what do we have? We've got 5 plus 1, which is 6, divided by the numerator of the denominator there, 5 to the minus 2. Let's make that 1 over 5 to the 2, so 1 over 25. Okay, and then we're going to say 6, we're going to tip in times, so make that a multiply. 25 over 1, which we don't really have to write. And then 6 times 25 is 150. So there we have it. Prime bases. Once we had those, we could factorize. Only once we factorize can we cancel. Why? Because our initial question had more than one term in the numerator. And once we've cancelled, we just need to sort out these constant terms.